In our last video, we made a Wi-Fi controlled 3D printed smart lamp. There's one small problem. It only works over Wi-Fi. And as we all know, Wi-Fi is great right up until it stops working, which happens to also coincide with when my wife attempts to turn the lamp on. So today, we're going to use vibe coding to mash up an old school improvement to the lamp. We're adding a button. That's right, a physical button, the kind you press with your finger. By the end of the video, you will have the practical knowledge to make changes to your lamp or other electronics projects using AI coding. And you'll have a lamp that toggles between low, medium, and high brightness. No smartphone required. If you're interested in making a lamp of your own, go check out that video linked in the description below. Okay, so here's the game plan. We're going to modify the lamp to add that button. We're going to use AI to vibe code the changes, and I'm going to show you how to upload those changes to your lamp. So here's what you'll need. A non-latching push button. A push button like this, where when you push it, it pops right back out. Kind of like a garage door button. Not like a traditional light switch in a house. You'll also need a drill and a drill bit that fits the size of your button, an X-Acto knife to clean out the hole that we're going to drill into the lamp, a wire stripper and cutter, about 6 inches of wire, some solder and a soldering iron, as well as a tape measure or a digital caliper. Step 1. Hook up the button. Have that button installed? Great. Time to summon the digital genie, aka ChatGPT, as we start our coding process. ChatGPT is not the only tool you can use for this, nor is it even the best tool, but it's free and simple for our basic lamp. When asking AI to write some code for you, try to imagine what would happen if your instructions are taken literally. AI will fill in the gaps, but the more clear you can be on your desires, the better AI can accommodate. As you gain knowledge, you can be more proactive in your prompts and give AI more and more information to work with. So I could say, hey, AI, add a button to this lamp for me, please. And if I didn't say anything more, it might add a button that turns it on and off. It might add a button that changes the color. What I specifically want it to do is change the brightness of the white LEDs from low, medium, high, and off every time I push the button. If I don't say that, AI is going to make up what it thinks it should do. Sounds simple, right? It actually is. It's like magic, except instead of a wand, we use copy and paste. So here we'll go ahead and enter our prompt into ChatGPT to add code to our existing code to make that button work. In our case, we know that we already have existing code that works without the button. So we can paste that code in to give AI a knowledge of where we stand with the code. From there, we can say we have a button that's going to be attached to pin D2. That's specifically the pin that the circuit board in our lamp kit is wired for. Lastly, we know that the functions that we want are off, low, medium, and high. And so we can put all of that information into our prompt to get AI to produce us new code. Now, sometimes AI will produce just snippets of code. You can either take those snippets and put them back into your code, or you can ask AI to write the entire program for you so that you can just copy and paste. We'll do the latter for right now just because it's simpler, but as time progresses, I encourage you to learn a little bit more about how to copy and paste the snippets into your code so you have a better understanding of how things are structured. Now that we have our new and improved code, it's time to try it out. You need to download and install the Arduino IDE. Add ESP8266 under Board Preferences. Then all you need to do is paste your code from ChatGPT into the Arduino IDE. Control A, Control V. Next, to flash the chip, what you can do is select Other Board and Ports, type in Node MCU and pick the 0.9 ESP12. And then when you plug in your ESP chip, you'll see it appear in this list over here. So there you see COM7. Click OK, and then you can go ahead and send or upload that to the ESP chip. If you run into any issues when you're trying to transfer the code over to the ESP microcontroller, you'll find an error posted on your screen. So here it says compilation error, Adafruit NeoPixel, no such file or directory. That's basically because some of these libraries you have to download individually. Let's go ahead and show you how to do that now. So if you click on the library icon, first we can do the NeoPixel library by typing in NeoPixel. And you can go down here to Adafruit NeoPixel, click install. If you haven't installed some of these others, you will also need the Arduino JSON. And you will also need the Wi-Fi manager by EasyAPU. Once you have all those installed, you should be able to go ahead and click the upload button and transfer that program to your microcontroller. This was a fairly simple task for AI to accomplish, so I'm not expecting any issues with compiling the code or the code even working. But that's not always the case. Okay, once that's done, you can go ahead and unplug your ESP chip and plug it back into your lamp. That's it. Congratulations, you're officially a lamp firmware developer. So let's recap. We added a physical button to our smart lamp. We modified the 3D model by drilling into it. We used AI to code the logic for our new button. And we flashed the ESP8266 using Arduino IDE. And now we have a lamp that responds to both Wi-Fi and button presses. The best of both worlds. If you like this lamp project and want to see more, feel free to hit that subscribe button. Thanks for watching and have a great day.